I'm Mark Miller. Norm Hardy is my mentor on all things security and capabilities. The way we met is I wrote a set of papers I was published in 1988 on agoric open systems, trying to lay out this vision of market-based computing. And we were working backward from this vision to what the requirements are for the platform. And we laid out a set of simultaneous requirements that no system that we knew of had met, and we frankly did not know whether all those requirements were simultaneously meetable. And it was basically a principled capability foundation where the capabilities were used not just in the traditional ways for access for sending messages and invoking services, but also for the computational resources, the memory space, the processor time, so that you could actually create a market in computational resources. And satisfying all the simultaneous constraints was something we just couldn't figure out how to do. But we published the papers anyway, laying out the requirements. And then Norm Hardy contacted me and said, I've got a system that satisfies all these requirements. And this led to a very, very long collaboration starting in the late 80s. And the system that Norm was talking about that he built is called Keynote. And there's this like 10-page or so architecture, the Keynote architecture explanation. And for me, it was one of those big epiphanies reading that thing. It's one of these tight documents where everything's mutually recursively defined in terms of everything else. So the first few times you read it, you can't figure it out. And then once you're sort of oriented enough, then you read it and everything fits together. And ever since then, I can't imagine how a good operating system could ever be constructed otherwise. It was sort of, he'd solved the entire problem, and you saw how everything fit together perfectly. There were 2.5 years where Norm and I shared an office. And it was during those 2.5 years, I really think of that as my security apprenticeship, where I just continued to pose one question after another to Norm. I kept trying to find an attack on Keynote, or even something I could improve in the architecture. I like to, tried to invent something that would be an improvement on the architecture, and for 2.5 years, Norm every time was able to convince me that no, actually the way he did it in Keynote was right. I've never seen anything, any engineering artifact that seemed as perfectly constructed. Norm and I also worked together with a bunch of other collaborators on moving the insights from that back into programming languages, which led to a lot of the work on programming language-based object capabilities that I've been involved with, that many of you know about. With that, I will turn it over. Oh, I should mention, Norm is attending remotely because of a last-minute medical emergency. That is, with that, I'll introduce my keynote speaker, Norm Hardy.
Well, thank you. Thanks for the compliments. Well, let's see. Okay, let me tell you where I got started. Oh, am I on the screen now?
You are.
Okay.
Your face is small, and the text from your webpage with "Who am I" at the top is big. It's on the screen. Everybody can see it.
Okay, excellent. Okay, graduated from Berkeley in 1955 in math and physics. I went to Livermore because they had the biggest and best computers. I did physics and math there. And then later on there, I did with an awful lot of help, I did a time-sharing system for the CDC 6600, which was styled after the earlier MIT CTSS compatible time-sharing system. Silicon Valley was beginning to bubble in 1966, and I went to IBM's ACS project. That folded up, and I joined Timeshare, which was a new, small time-sharing company. I worked there on operating systems and TimeNet. We began the Keynote project there. timeshare investors decided that the new personal computer doomed their business model and wound down that profitable company. We bailed out of timeshare and started KeyLogic and continued working on Keycos. We did some OS contracts, but too often we heard, we are sure that when security becomes important, someone will provide a module for Unix that will fix all of the problems. I think we then came across as trying to boil the ocean. We got encouraging noises from NCSC out of NSA. There were the people officially appointed to evaluate operating systems for security. But the government market was uncertain and KeyLogic shut down. Okay. Today I want to speak about CAP savvy. Oh, CAP obviously is capability. I will switch back and forth. Sorry for the confusion. A CAP savvy OS and how it relates to language design. There are at least two motivations here. These are two areas where capability ideas have been adopted, and when that happens, good ideas flow both directions. I will mention some of those ideas and hope for more in the future. Actually, I want to describe a capability system built on conventional hardware, which preserves most conventional software. My goal is to convince you that it is feasible. You don't have to boil the ocean to get there. Such security is necessary for many of the goals of this meeting, and it would be a nice neighborhood. That's far too much to ask, but perhaps I can convince you that it may be possible and worth some further study. I will talk about the Keycos OS mostly because I'm familiar with it. There are a few others as well, some recent. I will click on some of these links, and not others. I will not dwell on them. It would take us days instead of an hour. There are many good predecessors, and there are some new ones that I don't even have listed here. I consider this a wonderful opportunity to begin conversations. There's my email address, and better, what I plan to say here today and much more is available at this URL. And
Norm, scroll. Okay, good. Stop right there, so everybody can. The URL was split between lines, so just stop there. So.
Okay.
Okay.
Let's fix that now.
Okay, that's fine.
I want to echo something that Markham said. When we first got started on this in 72 through 75, we were not at all sure that capabilities were going to solve all the problems. We were pretty sure that we were going to use ideas out of capabilities. But every time we came to a hard problem, we looked at the solutions outside of the capability realm and inside, and universally opted for the capability solution. So I think Keycos actually stuck to the straight and narrow regarding capabilities. And I say that because it's not absolutely clear that capabilities is the right way. It wasn't clear to me in the beginning, and it's only in light of a lot of subsequent experience that I've come to think that they are the one and only way. Okay, these are a bunch of things I want to talk about, sort of where the bulk of my talk goes. And here is some stuff I won't cover excepting one down here. Early in the 60 to 65, computer manuals began to describe ideas that looked like this. CPU attached to an MMU, memory map unit, attached to RAM. Some of those manuals, while trying to describe the purpose of the MMU, would mention, well, if the program touches an address that is not there, the kernel will get control, and the only thing for a kernel to do in such cases is read a page off the disk and put it in memory. Those engineers, or technical writers, I don't know which, were vastly underestimating the power of this pattern. In the capability, I had just read and listened to lectures on a great deal of the upcoming Multics architecture. And this insight was from Multics. Given a virtual address, you draw a line somewhere up toward the left side, and everything to its left is a C-list index. That's that's one of the primary things that you expect out of a capability system. The insight was that the conventional hardware of 1965 was capability hardware, or at least the high performance part of it was capability hardware. And Keynote adopted this. Let's see, where am I? I think I'll dive in here, introduction. Today you will hear many thrusts to facilitate mutually suspicious programs cooperating over communication links. I address here mutually suspicious programs cooperating inside one system where messages cross protection boundaries in a few hundred clock cycles, less than a microsecond. 3 or 4 orders of magnitude enable classes of applications, and it is also critical for the security of distributed applications. This technology originated when computers were expensive, shared, and operated by some widely trusted organization. Today, the same technology promises a platform where critical functions can operate while relying on a megabyte instead of a gigabyte of correct or at least benign software. A few orders of magnitude help here too. With the proposed technology, there may be gigabytes of useful code on your personal computer, but your critical functions rely on less than a megabyte. I think there are no such solutions today that are deployed widely. There are some in the wings waiting to make announcements, perhaps. I don't know. Capabilities support a variety of patterns that solve security problems. Programming languages, at least since ALGOL 60, have limited access to variables so that one could confidently reason about a small part of a big program while considering only the source of that small part. Capability notions extend that to OS scope. Anyone wants to interrupt? This is a small group, and I think interruptions would work fine. So, okay, conventional platforms generally lack features to load programs from mutually suspicious user into one address space, so that they can communicate with the performance of modern compiled code, and also rely on the protection inherent in some modern language designs. That's not what Keynote does, but I'm suggesting that is an idea that should bridge the gap, that language design is in a position to solve some of the same problems that Keynote does. I worked out a version of the read, evaluate, print loop for the language scheme, where you had several competing, not mutually trusting users logged in to the same address space, sending messages back and forth. There are details here worked out for scheme, which I won't go into, but it's all online. The languages have almost systematically, avoided the problems of space and time. Mark mentioned this. And we discovered that you can buy space through invoking a capability, and you can buy time by merely possessing a capability.
Norm, just want to interrupt you for a moment.
Yes.
We're seeing your face animating, but we're not seeing the text scrolling. And it sounds like you're talking about a part of the text that's not what's on the screen.
Oh, okay. There should be an OOPS at the top of the screen. Do you see that?
I do not.
Oh dear. What do you see?
So at the top of the screen is YCAP platforms, short version. As long as what you're doing is just textual, I would say don't worry. Oh, it's scrolling now.
Okay, good.
Okay.
Let's see, where am I? Oh, here's where I meant to take off.
Okay, good. It says OOPS at the top.
Yep.
Okay, great.
So this role, classically in an operating system, if you and I are running C++ programs and I forget to free some storage, that storage is not permanently lost. When my program ends, the operating system cleans up after me, and it's there for the future. And we discovered that that can be easily included in the capability paradigm. We decided to expose as much of the hardware as we could. We missed a few things, and SEL4 goes even further in that direction. I mentioned the memory map of in the 1965 era. The Keynote exports that to user mode programs so that they can conveniently do things with the memory map that were not initially noticed in 1965, with little modification to the hardware, little or no modification. All of the things I will talk about today are possible on the 370, which came about in about 1975. So we got as close to the hardware as we could, and in such systems you allow programs written in various languages to securely communicate with each other, getting the combined separation properties proposed by the language designers and also the operating system designers. I have a grand plan here, which I will go to in more considerable detail, but not yet. And it assumes classic hardware protection, which modern hardware still claims to deliver. When people speak of capability hardware, there are two main thrusts. is the segregated capabilities. Okay, I won't spend a great deal of time here. Some people put a word in memory of their hardware to remind the hardware that what's here is a capability and not data. Others hardware-related capability systems segregate by pages. Some pages are good for capability, and some pages are good for data. There was a wonderful system which we would have learned a lot from if we had known, the Plessy 250, which I won't go into a great deal here. In fact, I won't go into at all. It was a capability system designed for telephone systems, and there are rumors that it runs today in some British military email applications. I have not been able to verify that. IBM has been into this area, and there is much to learn from them, but IBM's attitude was that only IBM would be competent to understand capabilities, and that's obviously not my attitude. The grand plan allows gigabytes of familiar application software to run inside the system securely, even when your security-critical applications are relying on a small fragment of that software, like a megabyte. I have a tendency to forget the user. Apple is the very opposite. They remember the user very carefully, and there are some conflicts here, which I won't try to hide. On the other hand, if you have a power plant to run or a car to drive, most of the details do not involve the user. And, well, I will. That was the introduction. Now I'll go back and dive into some of these other more narrow areas. Well, first of all, I got to say, what is our take on capabilities? There are many parochial definitions of capabilities that each come from some vantage point in the space of computer ideas. By definition, here, my definition is also parochial. Keynote started as a conceptual hardware extension of conventional computers of the mid-60s. We even considered putting it in microcode. We never did. Okay, here are some vague rules. They're not very precise. Only objects hold caps, and caps hold objects. Each object obeys its own program. Objects also hold read-write access to their own data. These programs cause the object to send messages, including some of their data and caps, via one of their caps. Messages, excuse me, I'm having a problem today. Messages sent via caps are delivered to the objects that the cap designates to be interpreted by the program that those objects obey. There is a religious discussion here, which I won't go into. You can find over here on this link. Caps and data are both located by program-supplied addresses. We're all used to programs having to know where their data is at by address in order to use that data. Same goes for caps. There was for a while a notion in Unix of adding caps where the operating system would, when you tried to do something, it would search through your capabilities to see if it could find an excuse to do so. I won't dwell today on why that was a bad idea. Objects have behavior and state. This is another direction to come from it. The behavior depends on the program that the object obeys, which is machine language in our case. The state is coded in the current state of the program's data. Two objects may share behavior, but not the state. And here is where definitions of objects differ, and there's a big quibble here. And so we're working on muddy territory, and I don't know that anyone has turned this into precise plain English. I would like to, but I have not succeeded. But yet capability experts seem to agree as to the essence, even if not the details of how to describe it. Another important thing about object-based system is that just about anyone in the system on the outside or the inside can create new objects. They can provide the code, and what they can't provide, what is only enforced by system rules, is what capabilities they can get their hands on. There was in Keynote a peek capability where you could look at any cell in real memory. This sounds terribly dangerous, excepting for the fact that in most configurations there were no keys, there were no capabilities to this object, and so it couldn't be invoked. Okay, there are three important areas that I'm aware of where capability notions are being applied, I think, well in each case. The platform level, the language level, and communication protocols. Platform means OS or some other sort of system that hosts software applications. Language solutions have pretty much ignored some of the necessary elements. Platform solutions operate on a coarse grain that solves many important problems, but not all. These levels should be made seamless, or there should be places to stand from which they seem to be seamless, or where the seams are invisible. I'm not sure anyone has succeeded at that. Not Keynote, although we've made some progress. I'm having a conceptual. Oh, here we go. Excuse me, as the speaker, I should have figured out some place to get a drink of water. I will be back in 10 seconds. Bye.
This is Norm Hardy's lab.
Sorry about that.
Yes.
Let me, at this point, describe something which maybe you can give me some help in. This is a question which I don't pretend to have an answer to. Conflict in styles. All of the computing languages that I like have nested scopes, a hierarchical tree structure for the top-level syntax. I find that this hierarchical nature of scopes is my friend. But when I design Keynote objects, I feel good that there is no status in location. It is not where you stand, but what capabilities you hold that entirely determines your status or privilege. I need to resolve this conflict. And in doing so, I think there are some new ideas that will come about. Okay, if anyone has some ideas, I'd love to hear from them. Space and time, I think we've pretty much talked about that already. Mark introduced it. I've already said that. Running too long. Keycoast has a tree of meters with a root, and if to run, you've got to be attached to one of the leaves of this tree. And there are programs here and there that have the capability to reach into one of the nodes of this tree and turn off everything below. That does not destroy your data. He can turn it on again. And this is a scheme for removing some scheduling-like functions from the kernel. I think I've said enough there.
Norm, I'm just going to interject a little historical note. Many people have seen some of my examples about something called the Mint Maker, a system of money with purses. That was actually very directly inspired by the Keycoast meter. And the first form of it was actually a tree structure that was much more directly like the Keycoast meter. So these ideas between allocating time versus allocating money are just very directly translatable into each other.
Thank you.
I have a historical segue type question. So Norm, you mentioned that you worked on capabilities starting about 1960, and you mentioned that the classic computer was 1970. How did you share your knowledge at that point? Today it's very easy. We're on Skype and we're using advanced telecommunications, but how did the two systems evolve at that point in time?
Well, 1972, Dale Jordan and Bill Ware and myself began each Thursday afternoon. We had gotten to a point, timeshare had gotten to a point where we could afford a new operating system design, and from our requests from our customers, we were beginning to realize that we needed to provide services that are classic operating systems, which very much like yours, but actually somewhat like CTSS, not as good as Multics. Well, anyway, we started in '72 and spent a few months pounding out the early ideas of capabilities, reading some papers, missing some. We should have been aware of Dennis and Van Horn. We were aware of Hydra and learned some things to do and not to do from Hydra. Algol 68 had just come out, and there was a bigot among us on that subject, and so we studied that manual very carefully and got a number of ideas. There are a few papers. Let's see, I don't recall when the Keycoast architecture paper was published, probably about 1980. And that we had a few hype style releases before then, but nothing substantial before the architecture paper, I think. We had the great good luck that Timeshare acquired the Engelbart WYSIWYG it's sort of like a WYSIWYG web, and it was designed for projects like ours. And so we immediately got access to that and kept our documentation there. And that was a huge benefit. The manual that exists today is an ossification of that manual because the web does not come up to the standards of. I don't want to start talking about Engelbart's system because I wouldn't finish. I'm sorry, I'm not sure I answered the original question.
I think that was very helpful. I would just like to add into that about your note about the Class E250 still being used. I was actually in signals intelligence in 1983, and we were using that unit then. Although I was, I gathered at that point in time that the British never actually threw anything away. So it's probably very likely they're using it today.
Yeah, there was a note on the Cap Talk mailing list from somebody, I've forgotten who now, that it's used in the mobile missile launchers.
Yeah.
Oh.
I didn't want to say so, but that's what we were using it for back then as well.
I feel much more comfortable, thank you. Okay, and that's wonderful to hear. That's more ratification than I had previously. Okay. Well, here is some typical rant that you will hear at any capability talk. Global mutable state isn't bad. If you know anything about Scheme, I love Scheme and it gets almost everything right. But there's a short statement. I can refer to the variable car, which means in Scheme what it means in Lisp. And I can change it to 0. Reading the manual, you would at first think that kills everyone's program because there are a few Scheme programs that don't use car. So that's a blunder. Algol 68 took the opposite design where they defined integers and tuples of integers which were immutable. And then, as a second take on it, it described a cell that could hold a value. Rees proposed a modification to Scheme that followed that, which I think is a substantial improvement on one of the few substantial improvements on Scheme. We learned from that, although the hardware prevented us from using that in the obvious sense. When we talk about a read-only page, there is in fact a mutable page down at the bottom. We just arrange for people not to be able to mutate it. Let's see. Well, let's see. There are a number of applications that I wish I had on my Mac, but they each have their own proprietary installer, and these installers each demand enough authority to essentially wipe out my Mac. And so I do without these applications. OCaml, which is a language which I like, has gone this route recently.
Sorry, OCaml, say more about what OCaml has done what recently?
They have provided a program which wants root privilege, well, no, it wants write access to all of my directories so it can store in a few of them. And that's recent. And if anyone thinks that I'm wrong, I would love to hear from them because I may be wrong. Keyco's never shuts down. We have been criticized for this. Being able to shut down the system is sort of a last resort of various things, such as your audiovisual system hanging up. And when you can't shut down a system, if you bring back a system and find one of your applications still stuck, what do? Well, actually, we found this in our own personal experience, being bigots, to be good, because we fixed the applications. There's also a fairly general way to hierarchically kill off parts of the system and start them up again. Just the same way that the Macintosh can kill an application that's looping. But the system as a whole restarts from checkpoints. There is a problem which I will refer to, and we don't have tested solutions. Keycos ran restarting only from checkpoints for a matter of several years, and one of the cases that I was familiar with, we were beginning to get to the state where people had taken early actions of granting some access, and they had forgotten what those actions were. And remembering what those actions were relevant to the current security situation. This problem must be addressed for a persistent system, and we have no proven solutions.
So I'm going to interject here and mention some of the work that Alan Karp and Mark Stiegler did on a system called Scoops, a capability-based file sharing system, in which the human-to-human act of sharing left behind records of the sharing actions together with the ability to attenuate what was shared. So basically, it creates at the level where you have agents that might want to look back at the sharing actions they've already done, the user interface for keeping track of those and for revising what was shared.
Yeah, it was more than just the user interface. It was every decision left an artifact. And whether it was handled by a human or a program was a side thing.
Mm-hmm. Yeah, the reason why I bring up the humans is that with the program text lets you statically know all of the things that it's never going to decide in the future. So if it's never going to decide to revoke, you don't need to create a revocable forwarder, but humans can always change their mind.
Thank you. I wish I had said that. Okay. Okay, here's just a short section. The security of Keycos back in 1980 was the machine room, the security perimeter. You assumed that bad guys couldn't get into the machine room. The security perimeter for Intel's SGX is the CPU chip. And I believe that Intel intends SGX to convince Hollywood that Intel chips are capable of safely protecting Hollywood's proprietary information, protecting it from the user. My plan here is more focused on protecting secrets and the integrity of the affairs of the owner-operator, the user. I propose a perimeter about the size of a cell phone or laptop. I think the Keycos could make arrangements with Disney's that are compatible with this, with their requirements as well. But that might amount to a tamper-resistant hardware, which I'm not sure is feasible. I don't know. Okay. Well, here's the deep dive, the anatomy. I don't know whether you can distinguish the two kinds of smiley face. Well, one is the smiley face number 2.3, and the others are meant to be suspicious. The capability kernel, which is all of the privileged mode code, must interpret every message sent to it or every call skeptically and make sure that it is not tricking it into doing something it should not do. There are several other classes of code in that category here too. We'll get to them. So the capability kernel is small, perhaps half a megabyte, perhaps even smaller. The capability confined miscellany are a bunch of stuff meant to bring you up to the state that most kernels are expected to deliver. There's the allocators where you get space and time, and a few other things like access to the network. There are various shared mutable objects that users of the system communicate with each other with. And there's merely convenient things that you could do for yourself that operating systems are expected to deliver. So layers 1 and 2 are roughly to get you up to normal kernel functionality. But that functionality is quite unconventional. And I'll talk about legacy environments. These tools are a motley collection of whatever is necessary to accommodate legacy programs. By legacy programs, I mean some program that runs on Linux or Mac OS or Android. Some environments host more than one legacy app and allow legacy style communications. You may have a collection of Unix programs that are designed to communicate by Linux rules that we don't want to mess with lest we break those programs. We had a little bit of that in Keynote, not much. As we started on this miscellaneous collection of adapters, Unix adapters, actually in the 370, when we brought over the compilers from that IBM had already moved from MVS to VM370. They moved those compilers over without changing the binary. They didn't even recompile them. CMS just provided the functionality that those compilers had come to expect. We followed the same pattern in Unix, and it worked very well. On the Luna 88K, where we had that system, we had a Keynote running there on a machine built but never commercialized by Omron, and we discovered that we could not compile X11, but we also discovered that we could run the X11 that came with their Unix bit for bit. We didn't have to reassemble it. We could put enough fakery around the edge to satisfy it and get all the X11 function that we needed.
Yeah, Norm, I'm going to interject. There's a very good paper that Jonathan Shapiro is the main author on the Keycoast nanokernel architecture that's really mostly about the rehosting of Minix
Yes.
and the decomposition of Minix onto Keycoast.
Ah, yes. Yes, I don't have a pointer to that here. That's a very good paper.
Can you say a word about how that relates to your plan in item number 3 here for the rehosting and decomposition of legacy OSs on a capability microkernel?
Well, I'm not sure how well it fits, but let me say the following. There is some emotional bias here. I have seen cases where someone comes up with a good kernel, someone emulates Unix on it, and what you end up with is the slow Unix. And so this is partly a strategy to avoid that outcome. I don't know whether that answers Markham's question. I think it doesn't. Something that I should suggest I mention somewhere, we got started on this as a quick and dirty project, and it never ceased being a quick and dirty project, although it was beginning to be quite useful. We didn't regret not implementing more of a complete Unix kernel. Of course, there are level 4 is native applications, and we had a number of those. A code written with capabilities in mind. Then there is a terrible layer 5, which tries to help the user understand what's going on and where the user can describe to the computer what his concerns are, and the computer can describe to the user what the ramifications of his choices are. Apple thinks they will take care of all of this and hide all of this behind the scenes. I think that is not feasible. Well, it may be feasible for a large category of Apple customers. I think it is not. It proved not to be adequate for the Democratic Committee. What was?
But that's the.
Yes. They needed more help about understanding what their actions amounted to. All too often, the Apple pops up a window on my screen asking me for a password. I don't know who is asking me. I don't know what authority it is presuming. I don't know what authority it is asking for. I don't know what authority I am presenting to it. I don't even know if it's Apple software. That all comes into the category of level 5, and it's a difficult problem. I described the icons here.
Sophia, go ahead.
Could you elaborate a bit on what you said about the user describing to the computer their concerns, and the system describes to the user its concern? Is that something that was available possible in Keycoast, or something that you were envisaging?
That was not available in Keycoast. We have nothing. I'm just pointing out the problems here that any such secure system, I think, has. We had ideas that we poked at. Some of the CapDesk stuff that Markham is more familiar with is more relevant than anything that I know.
Yeah, let me I'm going to stand up and just give a little bit of the bizarre history of capability user interface work. During the 2.5 years that I mentioned at the beginning, where I was kind of apprenticing myself to Norm, where we were sharing an office, we were working with modern graphical user interfaces. Keynote had been done all in the era of command line user interfaces. And Norm made this comment to me that was kind of this Zen koan. He said, the clipboard is inherently hostile to capabilities, and drag and drop is inherently friendly to capabilities. And it just stuck in my head as this weird mystery of trying to decipher one of these pronouncements from Norm. And it was a group of us talking about this that led to Mark Stiegler's invention of CapDesk and Ka-Ping Yee's writing of the seminal paper on the criteria for secure user interfaces, on the 10 properties. I remember, what's the name? Do you remember the name of the paper?
No, I don't.
Okay, and then that led to a lot of work, especially by Alan and Mark Stiegler at HP Labs, the Scoops work that I was mentioning, and it's all about surfacing capability concepts into the user interface in such a way that I'm going to use a slogan from Alan, not one click for security. It was the basic idea there is that the user should not be faced with a dialog box or any interaction that they understand is just being about security. Rather, that the actions that they're taking through the user interface are about realizing functionality, but they're expressed in such a way as to produce an intuition about the security implications of the action.
The key, Martin, the key insight is Stiegler's, which is use acts of designation as acts of authorization.
Right, which is exactly moving into the user interface, exactly the philosophy articulated by Norm ages ago about sort of the definition of capability as bundling designation with authority. When you do a drag and drop, in general, our user interfaces are these vast engines of designation, basically saying this thing should operate on that thing. And we just take these acts of pointing in the user interface and we turn them into the acts of authorizing. It's by making the selection of what thing should operate on what other thing, you also provide the permission that enables the one thing to operate on the other. Yeah.
I guess I don't quite understand why pasting into
Oh.
an application isn't also designating.
So in CapDesk, we actually did support did support a clipboard, and we did make it consistent with capability principles. But Norm, I'm going to try to represent what I take to be what your mysterious phrase was trying to say, and you correct me if I'm getting it right, if I'm not getting it right. But basically, the clipboard is a global variable. There's one clipboard, and if you take, it's not. There's a phrase that Alan likes to use: consistent under composition. If over here I take a drag and drop action and drag this thing and drop it over there, and then separately, either before or afterwards, I take a drag and drop action of taking this thing and dropping it over there, the two things have no coupling to each other. But over here, if I copy something onto the clipboard, and then it's on the clipboard and I'm distracted and I do something else, and I think, oh, well, let's copy something else onto, and then I sort of remember the original thing and I paste the wrong thing. And what's the weird coupling is because there's this implicit global variable that all these actions are sharing, without having said which global variable they're sharing. There's no explicit act of designation that allows them to be talking about different clipboards. Norm, is that?
You remember it better than I do. I like everything you said.
But Norm, at least
I mentioned
Norm,
a little bit before, there are some places where a megabyte or maybe 2 at the outside is ample as a foundation to run a power plant or drive a car. It takes a lot more software than that to drive a car, but there are many things going on in driving a car that need their own security, not in the sense that we're worried that the Russians will learn, but that they will get confused, that the various parts will get confused. Sometimes you need to control communications, and driving a car will be quite complex. Or firing a missile is not much simpler. Okay. I think I would love to replace my clipboard comments by what Markham just said. He said it much better, so I'm going to skip that. There is a problem when you're designing a level 5, a layer 5 software for the computer to collaborate with the user concerning computer issues. There is a big issue of what the user is expected to understand, what the user expects, and what the user needs. Those three big areas which are a mystery to me, and I just list them here. There are problems. These are problems that I stay awake worrying about at night.
I just wanted to say, Norm, I'm more hopeful that we can, if not solve, at least address those problems.
Yes.
On addressing those problems, I noticed myself these days, I carry 2 computers. I carry a MacBook and I carry a Chromebook, because I find that the MacBook now offers me up very confusing command line. I need to run specific functions from the command line in order to use the Bash environment for development. Whereas with the Chromebook, I never have to worry about that at all. It's completely seamless, although I don't have a Bash environment. So the irony is I'm now carrying 2 computers instead of 1.
Yes. Let me see. Well, I think I'm done with this branch. I think we've covered everything here, but I meant to cover a lot of this virtual reality for legacy apps. I'm just playing with metaphors there. Virtual reality today fails to fool many people. It's for fun and illumination. In the world of applications, it's much more successful. And in fact, it's 2 ways. It makes the imported application thinks it's running in its familiar environment, and it appears to capability-savvy software as objects. And this picture down here is meant to, the circles are cap-savvy objects. The squares and triangles and pentagons are foreigners coming from other systems, adapted by additional code to appear as a cap-savvy application. The grayed area down to the lower right is with technologies such as QEMU, you can even import from other instruction set architectures. Square peg and round hole metaphor. A nice thing about Unix is their simple concept of a file. IBM, I won't go into IBM's. IBM, a file was a sequence of records, and records were a multivariate, multi-splendid thing. In Unix, a file is a sequence of bytes. We adopted that. And indeed, a These collections of information have dual citizenships in Keycos. We can map them into the Keycos Savvy application, and they serve nicely. And a imported Unix application will access them through Unix channels quite efficiently. That was significant to us. We parted ways when it came to the directory structure. Keycos has objects which, like Unix, map ASCII strings to capabilities, including capabilities to other directories. But Keycos has no global root, accepting a local simulacrum to fool some Unix program that thinks it's God. These directory structures in Keycos could be circular. They were not acyclic. An object did not have to exist in some directory. It didn't have to be indexed in some directory in order to exist. Whether or not you can find it in a directory in Unix seems to be your certificate for existence. We had a program that would understand the Unix-style path names, even going around loops, and accepting there was no dot notation in that syntax. Native CAP applications do not pass path names amongst themselves. They pass capabilities. And after several months of this ad hocery, it was seldom more than an afternoon's job to adapt one of the many useful Unix utilities, and usually without recompilation. We were following IBM in this path. IBM brought a lot of utilities over to their VM370 system by this strategy. Let's see, is this the time to talk? Yeah, now is the time, I think, to talk about the domain keeper. Oops, excuse me. Let me plug my computer in. Okay. When a capability program is running, it means that some domain is obeying that program. Domain is sort of like a virtual CPU. It has a set of register values, and if there should be an invalid instruction in the program, the real CPU won't be able to execute it, and that throws the burden off on the kernel, which in this case is the CAP-savvy kernel. The CAP-savvy kernel invokes a domain keeper unique to this domain, and puts it in the domain keeper's lap. The domain keeper is just an ordinary Unix Keycos program, and the Keycos kernel delivers to the domain keeper just what a domain keeper should have in the way of authority. It delivers a service key to the domain. So, for instance, the domain keeper can read the registers of the domain or whatever else it finds necessary. And so the domain keeper is a Keycos program that serves what an ordinary Unix program expects to be delivered by the kernel. If the program touches a page that is unmapped, then the Keycos kernel will see if there is something it can swap in from the disk. If it can't, if the page is truly unmapped, then it looks in a, oh dear, I'm getting out of order here. I think I should. I think I need to go back to my text here a little bit. The domain keeper is very narrow. A given instance of the domain keeper has authority only over the one domain that it is handling. Plus, perhaps, if the Unix program does an open, then it expects to get a file. I'm sorry, I'm out of sync here. I'm going to talk more about keepers elsewhere, so let me postpone any further talk about the domain keeper. It's in charge of the illusion, is the short answer. All of this can be had for a megabyte or so code with infinite authority, and so you have to have complete trust in that code. There are many kernel-like functions. Here is a list of kernel patterns. These are patterns that a few kernels have, very few kernels. Linux and Unix have copy on write, which is a big functional improvement that goes beyond what the original engineers conceived. And here are a short list. I think I could triple the length of this list if I searched a few sites. All of these patterns can be implemented outside the capability-based kernel, and then thus available system-wide. Some kernels have actually adopted a few of these, but at the cost of trusting a lot of code in the kernel that few people need to be vulnerable to.
Norm?
Yes.
Since we have about 15 minutes left in the session,
Yes, thank you.
let's take a pause and see if we can, if there's some audience questions or discussion. Anybody have anything they want to ask Norm or raise in discussion?
I can answer his puzzle.
Okay.
So it's well known that you can make a static graph of capabilities, right? Where each node is an object, and then arrows are designations, right? If you allow to have multiple different paths within the graph be equivalent, then this is a representation of a category, and you can use category theory on that. You can use homology to compare different categories. You can take snapshots of categories in time and space and then compare them. So I don't know if that's a useful toolbox, but it's certainly one that's available.
Norm, did you hear that?
There was some breakup, but I got some of it.
Let
me see if I can say anything.
Yeah, just, why don't you just, Corbin, why don't you come up and just speak a little bit louder? We're using the microphone on the laptop.
Oh, the microphone's on the laptop.
Yeah, it's a good microphone though, but just speak up.
Okay.
Yeah.
Yeah. The idea is that you take a graph and then you augment it by finding all the equivalent paths and asserting that they're equationally the same, and then you get a category, and then you can use category theory. You can use cohomology from sheaf theory. You have a bunch of mathematical tools at your disposal at that point. So.
Okay, no, I am a rank amateur when it comes to category theory. I think there are important insights from there. I have not spent enough time to look there. I think what you say is promising, but I don't feel competent to reply to it. Types are very important. Types are the foundation of language security, sort of. And I haven't talked about Kiko's types. We have an alleged type. Oh dear. I have nothing immediate to say on that that's constructive, but there's some fascinating things here that I've left off the talk. I realize now. But I don't think I have any immediate answers to your question. But it's a good question.
Oh, Sophia?
So you mentioned types in Kikos. Can you talk to us about them?
I mentioned what?
Types.
Yes, types. And I was very surprised because, yeah.
Okay, that's an important thing here. Let me back up a little bit. Confinement is only an illustration of those types. Let me describe, when you invoke an object, when you send a message to it, it can reply any way it wishes. And if you don't trust it, it can claim. We have an alleged key type call, which I can ask you, how do you want me to view you? And that is obviously not secure, but for many types of objects, there is a creator of that type of object, which you have been securely introduced to. And so if someone sends you a message, and in this message is a mysterious capability, and you ask that capability, what sort of animal are you? It returns an alleged key type, and you can say, aha, in that case you would have been created by this here creator. You can send that key, this mysterious key, to the creator and ask it, did you create this? And that creator is in a position to give you an authoritative, secure answer. That's a fair amount of overhead, and we have not found a shorter way of giving you some of the benefits of types. And it's, you might imagine embedding this in a language so as not to make it quite so painful. But we've had to rely on this in a number of cases, several times in the confinement issue.
Yeah, let me mention with regard to languages, James Morris's seminal 1973 paper, Protection in Programming Languages, which was about the object capability language Gedanken, and he showed a trademarking mechanism, both trademarking and sealers on sealers, but the trademarking mechanism I think corresponds exactly to the branding mechanism in Kikos, even using the similar analogy. There's also a paper by James Morris called Types Are Not Sets, where he's very clear that the type is not a predicate describing something, but is an endorsement that it was created by something.
Yes, thank you. It is often necessary to know what sort of object you are speaking to. There are sometimes when you get this positive answer back from the creator, you may be willing to send your secrets to this object, now that you know what sort of object it is. Let's see. I'm going to, the kernel-like patterns, the important thing is that a kernel that reaches down and exposes much of the hardware to the user is in a position to deliver, it allows users to write user mode code that delivers the features that are inherently there. For instance, you can, Keynote's kernel does not provide copy and write. You can implement that outside the kernel. And 20 or 30 or 40 more useful patterns, such as a distributed segment that exists in machines in different cities, and you move the pages back and forth. That's quite difficult to do in Unix. It may be a bad idea, but sometimes, occasionally, it's a good idea. And I think, unless we really run out of time, I won't talk about the other patterns. There's a lot of them there, and you can look at them. I did want to mention one thing on debugging. In the language world, very often, if your program has some sort of fault and you fall into a debugger, all protection is turned off. It is assumed that the debugger has infinite authority over all classes. We could not take that attitude in Keynote because our customers needed to debug their programs even when they were interacting with the programs of other customers with differing proprietary requirements. So, long story short, we had a DDT, which was a second cousin to GDB, and it had control over just one domain. This actually, in my opinion, avoided a lot of confusion of stack frames. Often when you are looking at a crash, you have a number of stack frames available, and you forget the magic. I forget the magic of switching from one frame to another in GDB. So, long story short, all the debugging facilities were themselves confined to capability discipline. I think that's all I'll say on that. Confinement. I'll give you a very quick view of confinement. Butler Lamson defined the confinement problem many years ago. A confinement is when there is a program that you have provided on a machine that we share. I want to tell some of my secrets to your program because your program can do useful things to them and give me useful answers, but I don't trust you to see my secrets. And incidentally, you don't trust me to see your program. I think that's enough description of, and there were many subsequent papers just trying to solve that problem, well, at least a few. And the factory, I will claim, solves the original problem. And there is considerable use of what sort of object am I talking to there. And well, maybe this is a good time for me to stop. So maybe I'll just stop there abruptly and ask questions.
Despite many years working on capability systems, I'm still confused about the factories. Can you explain them briefly?
The factory?
Yep.
Oh, okay, I'll expand it in the previous. want me to be able to use your program, perhaps I'm paying you. And so you learned about the factory. You call the factory creator, there's two C's in there, and you get a new factory, oh dear. You modify the installation of your program so that it comes from a factory. And there are some details you have to learn. Your program needs certain facilities, and you can provide those facilities. What you deliver to me is the factory, and the first thing I gotta ask is this a factory? You deliver it to me in the form of a capability, and I see that it's a factory, and I invoke it, and when I invoke the factory that you sent me, an instance of your program arises, which can't talk to any of the other, it can't talk to you, it can't talk to any of the other instances of your program that may exist. And it doesn't have any outgoing links to send information. This is essentially when the factory creates an object, an instance, it's by inclusion, not by exclusion. It lists the things to include, not the things to exclude. I think that's
Well,
I need to have.
I think what you're doing is you're transferring trust from the other guy's program to the factory.
No, I think I got it, but I have to read more about it.
Yeah, Sophia, go ahead.
Do you think that the introduction is solves all the problems of what we said earlier about the system describing to the user their concerns and their requirements, and the user describing to the system their concerns? In particular, if I introduce A to B, is it enough? For instance, A might have the capabilities to C, and then he may decide to give them further, but I didn't want to. So I have got some feeling that introduction is not enough.
Yes, you have hit on a profound issue. It was an early issue. This is one of the areas where we differed from Hydra. Hydra, I could pass you a capability that you could not pass on. And that's like having a language with a subroutine concept where you can only have one level deep of subroutine. And that is a very bad idea. We worried about that. I talked to Maurice Wilkes, who designed a capability system long before we started. And his comment was, you can never be sure where these capabilities are going to get to. And confinement is a non-trivial, the factory is a non-trivial solution to the confinement problem. It isn't trivial, but it is possible. And it would take me another half hour to describe the details of that. But I think they're well described online, and I would love to talk to anyone about details that they find obscure.
I'm going to let's get.
Before you go, Norm, I've known you for a long time. I've heard you discuss this over and over, and I learned stuff today. So thank you.
Thank you very much. Thank you.
Thank you.
Norm, do you